The illusion of time. What's real? Time, an intangible force that governs our existence, is a captivating enigma that has perplexed philosophers, scientists, and thinkers throughout the ages. As we navigate the intricacies of our daily lives, time seems to march forward relentlessly, dictating our schedules, measuring our experiences, and framing our understanding of the world. However, beneath this seemingly linear progression lies a profound question that has intrigued minds for centuries. Is time truly an absolute and objective reality? Or is it, as some argue, nothing more than a subjective illusion woven into the fabric of our perception? In exploring the concept that time is an illusion, we delve into the realms of physics, philosophy, and psychology, challenging our conventional understanding of this elusive dimension and inviting contemplation on the nature of reality itself. Beyond the ticking hands of clocks and the calendar pages turning, the illusion of time manifests in the relativity theories proposed by visionaries like Albert Einstein. In the realm of physics, time becomes a malleable entity, bending and warping in the presence of massive objects or high speeds. This begs the question: is time truly a fixed, independent entity, or does it morph and adapt based on the circumstances it encounters? In the corridors of philosophy, the illusion of time takes on a different hue. Existentialist thinkers, such as Jean-Paul Sartre, posit that time is a construct of consciousness, a subjective framework imposed upon our perceptions. The past, present, and future, according to this perspective, are not inherent properties of the universe but are rather mental constructs that give structure to our experiences. Moreover, the psychological dimension adds another layer to this intriguing narrative. Our perception of time varies with age, mood, and cultural context. The fleeting moments of childhood seem endless in retrospect, while the relentless march of time accelerates as we age. Cultural nuances influence our perception of time, with some societies placing a premium on the present moment while others focus on a cyclical understanding of time. In challenging the conventional understanding of time, we embark on a philosophical journey that transcends the boundaries of scientific inquiry. The illusion of time beckons us to question the nature of our reality, inviting us to ponder whether the linear progression we so instinctively accept is a fundamental truth or a construct of our own minds. As we navigate this intellectual labyrinth, we may find that the concept of time as an illusion opens doors to a deeper comprehension of the cosmos and our place within it. Why is time controversial? It feels real, always there, inexorably moving forward. Time has flow, runs like a river. Time has direction, always advances. Time has order, one thing after another. Time has duration, a quantifiable period between events. Time has a privileged present, only now is real. Time seems to be the universal background through which all events proceed, such that order can be sequenced and durations measured. The question is whether these features are actual realities of the physical world or artificial constructs of human mentality. Time may not be what time seems, this smooth unity without parts, the ever-existing stage on which all happenings happen. And this brings us to our big question: is time physical?
To appreciate time is to feel the fabric of reality. An interview survey was carried out on physicists and philosophers on some public television series named Closer to Truth, and many assert that time is an illusion. What do they mean that time is not real? Hugh Price, professor of philosophy at Cambridge University, claims that the three basic properties of time come not from the physical world but from our mental states. A present moment that is special, some kind of flow or passage, and an absolute direction. Think of the block universe, which is supported by Einstein's theory of relativity, as a four-dimensional space-time structure where time is like space, in that every event has its own coordinates or address in space-time. Time is tenseless, all points equally real, so that future and past are no less real than the present. Time is, was, and will be. So, are we being misled by our human perspectives? Is our sense that time flows, or passes, and has a necessary direction, false? Are we giving false import to the present moment? We can portray our reality as either a three-dimensional place where stuff happens over time, said Massachusetts Institute of Technology physicist Max Tegmark, or as a four-dimensional place where nothing happens, block universe. And if it really is the second picture, then change really is an illusion, because there's nothing that's changing, it's all just there, past, present, future. So life is like a movie, and space-time is like the DVD, he added. There's nothing about the DVD itself that is changing in any way, even though there's all this drama unfolding in the movie. We have the illusion, at any given moment, that the past already happened and the future doesn't yet exist, and that things are changing. But all I'm ever aware of is my brain state right now. The only reason I feel like I have a past is that my brain contains memories. Time is out there, said Andreas Albrecht, a theoretical cosmologist at the University of California, Davis. It's called an external parameter, the independent parameter in the classic equation of motion. So, time, the time we know since we learned to tell time on a clock, seems to disappear when you study physics until you get to relativity. The essence of relativity is that there is no absolute time, no absolute space. Everything is relative. When you try to discuss time in the context of the universe, you need the simple idea that you isolate part of the universe and call it your clock, and time evolution is only about the relationship between some parts of the universe and that thing you called your clock. Julian Barber, a British physicist, describes time as a succession of pictures, a succession of snapshots, changing continuously one into another. I'm looking at you. You're nodding your head. Without that change, we wouldn't have any notion of time. Isaac Newton, Barber noted, insisted that even if absolutely nothing at all happened, time would be passing, and that I believe is completely wrong. To Barber, change is real, but time is not. Time is only a reflection of change. From change, our brains construct a sense of time as if it were flowing. As he puts it, all the evidence we have for time is encoded in static configurations, which we see or experience subjectively, all of them fitting together to make time seem linear. But not all physicists are ready to demote time to second-class status. John Polkinghorne, a quantum physicist and Anglican priest, believes that the flow and direction of time are real and relentless. It is a mistaken argument, he said, to use relativity to assert that time is an illusion. Because no observer has knowledge of a distant event, or the simultaneity of different events, until they are unambiguously in that observer's past. And, therefore, that argument focuses on the way observers organize their description of the past and cannot establish the reality of the awaiting future. Polkinghorne rejects the notion of the static block universe of space and time together. We live in a world of unfolding and becoming, he said. Time is a prime conflict between relativity and quantum mechanics, measured and malleable in relativity while assumed as background, and not an observable, in quantum mechanics. To many physicists, while we experience time as psychologically real, time is not fundamentally real. At the deepest foundations of nature, time is not a primitive, irreducible element or concept required to construct reality. Time's passage is probably an illusion. From the fixed past to the tangible present to the undecided future, it feels as though time flows inexorably on. But that is an illusion. The passage of time is probably the most basic facet of human perception, for we feel time slipping by in our innermost selves in a manner that is altogether more intimate than our experience of, say, space or mass. The passage of time has been compared to the flight of an arrow and to an ever-rolling stream, bearing us inexorably from past to future. Evocative though these images may be, they run afoul of a deep and devastating paradox. Nothing in known physics corresponds to the passage of time. Indeed, physicists insist that time doesn't flow at all, it merely is. Some philosophers argue that the very notion of the passage of time is nonsensical and that talk of the river or flux of time is founded on a misconception. How can something so basic to our experience of the physical world turn out to be a case of mistaken identity? Or is there a key quality of time that science has not yet identified? Time isn't of the essence. In daily life we divide time into three parts: past, present and future. The grammatical structure of language revolves around this fundamental distinction. Reality is associated with the present moment. The past we think of as having slipped out of existence, whereas the future is even more shadowy, its details still unformed. In this simple picture, the now of our conscious awareness glides steadily onward, transforming events that were once in the unformed future into the concrete but fleeting reality of the present, and thence relegating them to the fixed past. Obvious though this common-sense description may seem, it is seriously at odds with modern physics. Albert Einstein famously expressed this point when he wrote to a friend, "The past, present and future are only illusions, even if stubborn ones." Einstein's startling conclusion stems directly from his special theory of relativity, which denies any absolute, universal significance to the present moment. According to the theory, simultaneity is relative. Two events that occur at the same moment if observed from one reference frame may occur at different moments if viewed from another. An innocuous question such as, "What is happening on Mars now?" has no definite answer. The key point is that Earth and Mars are a long way apart, up to about 20 light minutes. Because information cannot travel faster than light, an Earth-based observer is unable to know the situation on Mars at the same instant. He must infer the answer after the event, when light has had a chance to pass between the planets. The inferred past event will be different depending on the observer's velocity. For example, during a future manned expedition to Mars, mission controllers back on Earth might say, "I wonder what Commander Jax is doing at Alpha Base now." Looking at their clock and seeing that it was 12 p.m. on Mars, their answer might be eating lunch. But an astronaut zooming past Earth at near the speed of light at the same moment could, on looking at his clock, say that the time on Mars was earlier or later than 12 p.m., depending on his direction of motion. That astronaut's answer to the question about Commander Jax's activities would be cooking lunch or washing dishes. See, it's all relative. Such mismatches make a mockery of any attempt to confer special status on the present moment, for whose now does that moment refer to? If you and I were in relative motion, an event that I might judge to be in the as yet undecided future might for you already exist in the fixed past. The most straightforward conclusion is that both past and future are fixed. For this reason, physicists prefer to think of time as laid out in its entirety, a timescape, analogous to a landscape, with all past and future events located there together. It is a notion sometimes referred to as block time. Completely absent from this description of nature is anything that singles out a privileged, special moment as the present or any process that would systematically turn future events into present, then past, events. In short, the time of the physicist does not pass or flow. How time doesn't fly. A number of philosophers over the years have arrived at the same conclusion by examining what we normally mean by the passage of time. They argue that the notion is internally inconsistent. The concept of flux, after all, refers to motion. It makes sense to talk about the movement of a physical object, such as an arrow through space, by gauging how its location varies with time. But what meaning can be attached to the movement of time itself? Relative to what does it move? Whereas other types of motion relate one physical process to another, the putative flow of time relates time to itself. Posing the simple question, how fast does time pass, exposes the absurdity of the very idea. The trivial answer, 1 second per second, tells us nothing at all. Although we find it convenient to refer to time's passage in everyday affairs, the notion imparts no new information that cannot be conveyed without it. Consider the following scenario. Alice was hoping for a white Christmas, but when the day came she was disappointed that it only rained. However, she was happy that it snowed the following day. Although this description is replete with tenses and references to time's passage, exactly the same information is conveyed by simply correlating Alice's mental states with dates, in a manner that omits all reference to time passing or the world changing. Thus, the following cumbersome and rather dry catalogue of facts suffices. December 24th, Alice hopes for a white Christmas. December 25th, there is rain. Alice is disappointed. December 26th, there is snow. Alice is happy. In this description, nothing happens or changes. There are simply states of the world at different dates and associated mental states for Alice. The event, Alice is disappointed, was once in the future, then in the present and afterward in the past. But past, present and future are exclusive categories, so how can a single event have the character of belonging to all three? Most physicists would put it less dramatically. The flow of time is unreal, but time itself is as real as space. A great source of confusion in discussions of time's passage stems from its link with the so-called arrow of time. To deny that time flows is not to claim that the designations past and future are without physical basis. Events in the world undeniably form a unidirectional sequence. For instance, an egg dropped on the floor will smash into pieces, whereas the reverse process, a broken egg spontaneously assembling itself into an intact egg, is never witnessed. This is an example of the second law of thermodynamics, which states that the entropy of a closed system, roughly defined as how disordered it is, will tend to rise with time. An intact egg has lower entropy than a shattered one. Because nature abounds with irreversible physical processes, the second law of thermodynamics plays a key role in imprinting on the world a conspicuous asymmetry between past and future directions along the time axis. By convention, the arrow of time points toward the future. This does not imply, however, that the arrow is moving toward the future, any more than a compass needle pointing north indicates that the compass is traveling north. Both arrows symbolize an asymmetry, not a movement. The arrow of time denotes an asymmetry of the world in time, not an asymmetry or flux of time. The labels past and future may legitimately be applied to temporal directions, just as up and down may be applied to spatial directions, but talk of the past or the future is as meaningless as referring to the up or the down. The distinction between pastness or futureness and the past or the future is graphically illustrated by imagining a movie of, say, the egg being dropped on the floor and breaking. If the film were run backward through the projector, everyone would see that the sequence was unreal. Now imagine if the film strip were cut up into frames and the frames shuffled randomly. It would be a straightforward task for someone to rearrange the stack of frames into a correctly ordered sequence, with the broken egg at the top of the stack and the intact egg at the bottom. This vertical stack retains the asymmetry implied by the arrow of time because it forms an ordered sequence in vertical space. Proving that time's asymmetry is actually a property of states of the world, not a property of time as such. It is not necessary for the film to actually be run as a movie for the arrow of time to be discerned. Given that most physical and philosophical analyses of time fail to uncover any sign of a temporal flow, we are left with something of a mystery. To what should we attribute the powerful, universal impression that the world is in a continual state of flux? Some researchers, notably the late Nobel laureate chemist Ilya Prigogine, have contended that the subtle physics of irreversible processes make the flow of time an objective aspect of the world. But I and others argue that it is some sort of illusion. After all, we do not really observe the passage of time. What we actually observe is that later states of the world differ from earlier states that we still remember. The fact that we remember the past, rather than the future, is an observation not of the passage of time but of the asymmetry of time. Nothing other than a conscious observer registers the flow of time. A clock measures durations between events much as a measuring tape measures distances between places. It does not measure the speed with which one moment succeeds another. Therefore, it appears that the flow of time is subjective, not objective. Living in the present, this illusion cries out for explanation. And that explanation is to be sought in psychology, neurophysiology, and maybe linguistics or culture. Modern science has barely begun to consider the question of how we perceive the passage of time. We can only speculate about the answer. It might have something to do with the functioning of the brain. If you spin around several times and stop suddenly, you will feel giddy. Subjectively, it seems as if the world is rotating relative to you, but the evidence of your eyes is clear enough. It is not. The apparent movement of your surroundings is an illusion created by the rotation of fluid in the inner ear. Perhaps temporal flux is similar. There are two aspects to time asymmetry that might create the false impression that time is flowing. The first is the thermodynamic distinction between past and future. As physicists have realized over the past few decades, the concept of entropy is closely related to the information content of a system. For this reason, the formation of memory is a unidirectional process. New memories add information and raise the entropy of the brain. We might perceive this unidirectionality as the flow of time. A second possibility is that our perception of the flow of time is linked in some way to quantum mechanics. It was appreciated from the earliest days of the formulation of quantum mechanics that time enters into the theory in a unique manner, quite unlike space. The special role of time is one reason it is proving so difficult to merge quantum mechanics with general relativity. The Heisenberg uncertainty principle, according to which nature is inherently indeterministic, implies an open future, and, for that matter, an open past. This indeterminism manifests itself most conspicuously on an atomic scale of size and dictates that the observable properties that characterize a physical system are generally undecided from one moment to the next. For example, an electron hitting an atom may bounce off in one of many directions, and it is normally impossible to predict in advance what the outcome in any given case will be. Quantum indeterminism implies that for a particular quantum state there are many, possibly infinite, alternative futures or potential realities. Quantum mechanics supplies the relative probabilities for each observable outcome. although it won't say which potential future is destined for reality. But when a human observer makes a measurement, one and only one result is obtained. For example, the rebounding electron will be found moving in a certain direction. In the act of measurement, a single, specific reality gets projected out from a vast array of possibilities. Within the observer's mind, the possible makes a transition to the actual, the open future to the fixed past, which is precisely what we mean by the flux of time. There is no agreement among physicists on how this transition from many potential realities into a single actuality takes place. Many physicists have argued that it has something to do with the consciousness of the observer, on the basis that it is the act of observation that prompts nature to make up its mind. A few researchers, such as Roger Penrose of the University of Oxford, maintain that consciousness, including the impression of temporal flux, could be related to quantum processes that take place in the brain. Although researchers have failed to find evidence for a single time organ in the brain, in the manner of, say, the visual cortex, it may be that future work will pin down those brain processes responsible for our sense of temporal passage. It is possible to imagine drugs that could suspend the subject's impression that time is passing. Indeed, some practitioners of meditation claim to be able to achieve such mental states naturally. And what if science were able to explain away the flow of time? Perhaps we would no longer fret about the future or grieve for the past. Worries about death might become as irrelevant as worries about birth. Expectation and nostalgia might cease to be part of human vocabulary. Above all, the sense of urgency that attaches to so much of human activity might evaporate.
In conclusion, the notion of time being an illusion raises profound questions about our perception of reality. Whether viewed as a human construct or a fundamental aspect of the universe, understanding time remains a complex and intriguing challenge.